Okay, so let us now look at another class of problems called the bankruptcy problem, which has close connections with issues that we have been talking about, namely fair division and cooperative claims. So in the bankruptcy game, we have the problem of having to split the assets of a bankrupt debtor among the different creditors that the debtor has, right? So let's consider an example and think about the main issues. So imagine that you have a debtor who has assets worth 100 units and the debtor has two creditors. Creditor 1 claims that the debtor owes him 50 units, and creditor 2 claims that the debtor owes him 100 units. Now, since the total claims is 50 plus 100, which is equal to 150, and is above the total assets that the debtor has, then we have to figure out a way of dividing this total asset among the different creditors. So the question that the bankruptcy problem deals with is how should the assets value be divided among the two creditors in this case. So we are going to think of this bankruptcy problem formally as a game which has the following components. So you have to specify N, which is the set of creditors of the bankruptcy debtor. Then you have to specify A, which is the total assets of the debtor. And you have to specify CI, which is the amount owed to creditor I, right? So in this example, we had N being 1 and 2. We had A being 100, and we had the claims being C1 equal to 50 and C2 equal to 100, right? So this is the description of the game. What are we trying to get at? So we are trying to figure out what is a way of dividing these assets into the claims that the creditors have, right? So a solution to the bankruptcy problem is basically an allocation xi to each creditor, where xi has to be less than equal to ci. So the amount that we are giving to each creditor has to be lower than the claim that that specific creditor had, and the total amount that we are dispersing among the creditors is going to add up to A, which is going to be less than C, which is the total claim of the creditors, right? In case you have got basically C is strictly less than A, then that's not necessarily an interesting problem, because then you can just give whatever the creditors are claiming, you can just give them that amount, and assets that you have, that is sufficient. So this bankruptcy problem is kind of like interesting when you have got A is strictly less than C. Okay. Now, what's the connection with the cooperative games that we have been talking about? So we can think of this bankruptcy problem as a cooperative game, where N is the set of creditors, and the coalition function actually tells us what's the worth of each creditor. Okay, so that's the CI. And the worth Vn of the total set of creditors is given by A, which is the value of assets, right? So that's the connection between what we have been discussing and this bankruptcy problem. So let's think of different ways that you can go about dividing the assets. So we'll see that there are like actually different principles that can be used. And our objective in this segment is to just give an idea of like what are the different ways in which people have thought about doing it. So one simple idea is that we should actually give creditor 1 double the amount that we are giving to creditor 2, right? Why is that? So remember that creditor 1 claimed 50 and creditor 2 claimed 100. So we should actually give creditor 2 the double the amount, right? So this is kind of like this should actually be reversed. So creditor 2 gets the double the amount of creditor 1, right? So then basically if we are splitting 100 into 2:1 ratio in favor of creditor 2, so then creditor 1 will end up getting 1/3 of 100, and creditor 2 will end up getting 2/3 of 100. So this is how we are going to split the two shares, right? So the description of the problem has C1 is equal to, remember, 50, C2 equal to 100. So then we are going to end up with A1 equal to 100 by 3 or 33.3, and A2 is 200 by 3 or 66.67, right? And so this is basically an illustration of the proportional rule. So what does the proportional solution say? So this solution suggests that we should split the assets in a way in which we allocate to each creditor I fraction A by C of the fraction of amount that they are owed, right? So this is the amount that we are finally allocating, AI. This is the amount that the creditor claims. So this ratio AI by CI is going to be given by A by C, where A is the total assets that are to be dispersed, and C is the total amount of claim, right? So again, just to make sure that this fits with what solution we have got. So remember, the first person is going to get A1. So that's going to be equal to A by C. So A is 100 here, C is 150. So we have got basically 2 by 3 multiplied by 50 or 100 by 3, which is what we have written here, right? And similarly for A2, this is going to be basically, again, going to be equal to the total asset. So this is 100 divided by 150 multiplied by 100, right? So therefore you end up getting 200 by 3, which is what we have here. Okay, so this is like the most natural rule that you have. Okay, but that's not the only way in which you could have split. So this is another way, and this is equally, I think, kind of like natural sounding argument. So the argument goes as follows: since creator 1 wants at most 50, that is the claim of the creator. So creator 1 is conceding the remaining 50 of the assets that are there to creator 2, right? So basically you have got a 50 portion which should go to creator 2, which is uncontested, and you have got the other 50 portion which is contested between this 1 and 2, right? And the second way of solving this division problem is to suggest that the contested part should be equally divided among the people who are contesting it, right? So this is actually a famous illustration of a well-known principle which goes back to ancient times, which is also known as the contested garment principle, because the original story that was there was related to contestation of basically a piece of cloth. So what it said was the following: so two hold a garment, both claim it all, then one is awarded half and the other half, right? So what this is saying is that if both are claiming the whole of the garment, then basically give each of them half. Okay. On the other hand, if two hold a garment, one is claiming it all, but the other is claiming it half, then one is awarded 3 by 4 and the other should be awarded 1 by 4. Okay. So now we can see, using the same principle that we discussed, how are we getting these numbers 3 by 4 and 1 by 4. So the idea is one is claiming it all, but the other is only claiming half. So the other is basically agreeing to give away half uncontested, right? So that half goes to the first person, but the remaining half is going to be equally divided between the two players. And so therefore the first person is going to get half plus 1/4, whereas the second person is just going to get 1/4, right? So that's the idea. Okay. So this is like the basic idea, but we can extend it to other different cases. So imagine that in this case, you have that the garment is worth 100 units of money. And player 1 claims that his share of the garment is 50 units. And player 2 claims that his share of the garment is 80 units, right? So the difference between this and the previous example is that in the previous example, only one was willing to concede a certain portion. Here, actually, both are kind of like willing to concede a certain portion, right? Because nobody is claiming an amount which is more than the total assets worth, right? So the question again is that, given the claims and given the value of the asset, how should we divide this value of the asset among the two different claimants, right? Okay. So we can use the same principle that is there, but just a bit generalized. So the idea is that because player 1 is claiming that his share of garments is 50 units, player 1 is willing to get 50 units uncontested to player 2, right? And since player 2 is claiming that his share of garments is 80 units, then he is willing to let go as uncontested 20 units. So this is the starting point, that player 1 is not contesting 50 units, so this should go to player 2, and player 2 is not contesting 20 units, so this should go to player 1. So that is how 70 units are decided. And the remaining 30 units, which is being contested, that should be equally split among the two players, right? So this is exactly what we have been talking about. So 70 units are divided uncontested, 30 units are split equally. So then we end up with the first person receiving 20 plus half of this 30, which is this 35. And the second person getting 50, which was the uncontested amount, plus half of this 30. So therefore 50 plus 15 is equal to 65, right? So that is how we end up with this split. Okay, let's look at another example. So this is again another modification of the two creditors case. So imagine that a man has two creditors. One creditor's claim is 300, the other's is 90, and the man's estate is worth 120 units, right? So here notice that one of the claims is more than the value of the estate, right? Whereas the other one is less. So again, we apply the same ideas. For player 2's perspective, the one who is claiming 90, this person is willing to kind of give away 30 uncontested, right? So out of this 120, this 30 is uncontested and should go to player 1 based on player 2's claims. The remaining 90 units are actually contested and so therefore should be divided equally, right? So we have got basically 30 units going to player 1 plus 45 units from the equal division of the contested amount. So that's 75 units. that player 1 who was claiming 30, and whereas player 2 who was claiming 45. So that is where this 45 is coming from, right? This is again this 90 units which were contested, that the equal division of that led to player 2 getting 45 units. Okay. So we can actually now generalize this idea that we are saying. So this is the contested garment method or contested garment principle. So the idea is, imagine that there is a estate E. There are creditors who claim D1 and D2, where D1 plus D2 is more than E. Now, why are we making this assumption? Because if D1 and D2 is less than equal to E, then you can just give them whatever they are claiming, right? So the problem only becomes interesting when you have got D1 and D2 such that D1 plus D2 is strictly more than E. Okay, so how do you do it? First, you figure out what is the uncontested amount. So from the person who is kind of like claiming D1, and then you have got here the person who is claiming D2. So because this person is claiming D2, then this was the uncontested amount is E minus D2. Now, the only thing is what happens if D2 is more than E, then this E minus D2 will actually become 0, right? Because you are not giving somebody a negative amount based on this, right? So what this means is basically this is the max of E minus D2 comma 0. So that is what we mean by the plus sign here, right? So for example, if we have something that E minus D1 plus, this means that this is an expression which is going to be equal to E minus D1 if E minus D1 is greater than equal to 0. And if E minus D1 is less than 0, then this expression should be read as 0. Okay, so that's the idea. So from person 2's perspective, right, who has claimed D2, this is the amount that is uncontested, right, which if it is positive is E minus D2, which if it is negative is equal to 0. And this amount should go to then person 1. And from person 1's perspective, E minus D1 is the amount that he is not contesting. And so this amount should go to player 2. Again, if this E minus D1 is positive, and if this E minus D1 is negative, then this whole thing should just be equal to 0. Okay. So this is the amount that is the uncontested part. So then we can, based on that, we can calculate what's the portion of the estate which is the contested part, and then we divide that equally among the two players. So that's what the second line is saying. And then basically if you add up, you end up this thing, right? So this is the general principle. You just need to be careful of, if you have a negative sign here or here, you should put that equal to 0 and kind of like follow up on that, right? So this is the same principle that we just illustrated. Okay. What are some other examples that one needs to think about? So far we have been talking about division among two people. Now let's consider a case where you have a man who has 3 children, and they are actually bequeathed sums of 100, 200, and the 300 in the man's will. Okay. After the man dies, it turns out that the estate's total is less than 600. Now, why 600 is the critical number? Because remember, they were bequeathed sums of 100, 200, and 300. So if you add them up, it's 600. So if you had the value of the estate as more than 600, then this would not have been the problem. The first child should have been given 100, the second child should have been given 200, and the third child should have been given 300. The only problem is what happens if you have got that the estate's value is less than 600, right? So the question is, how should we divide the estate among the 3 children? So one solution that again was proposed in ancient times was as follows. So these were the 3 claims, right? And based on the different values of the estate that were there, these were the suggestion, right? So one suggestion was, if the estate value was 100, then we should divide it equally among the 3 claimants. However, if the value was 200, then we should give 100 to the first claimant, 75 to the second claimant, and 35 to the third claimant. And similarly, if the total amount of the estate was 300, then we should divide it into 50, 100, and 150. Okay. So this seems a bit puzzling, right? I mean, the first one, not necessarily, because you have, this is like an equal share. But what about these 2 parts? The third one also seems something kind of like familiar, because if you think about it, it's in the ratio 1:2:3, which is what the claims were also in, right? But it's very hard to see where the second number is coming from, right? And also we are actually a bit curious about, can we somehow come up with a general principle that explains all these 3 different things rather than having different rules for different values of the estate, right? So this is where our discussion of this contested garment principle will help us. So let's unpack things a bit. So let's consider the second case. So here, remember, the estate value was 200 and the person who was claiming 100 got 50, the person who was claiming 200 got 75, and the person who was claiming 300 got 75. Okay. So let's consider the first and the third child together. So together they get 50 plus 75 or 125. Now let's do a thought experiment where suppose that we are deciding to give an amount 125 to the first and the third children, and then we are asking based on their claims uh, to divide it according to the contested garment principle, right? So remember the claims were 100 and 300, right? So if 125 is the total and if the claim is 100 and 300, basically the first child is conceding 25 uncontested to the third child. So the third child gets the 25 from here, and the remaining 100 is going to be kind of like contested, and so therefore it's going to be split equally, right? So from there you see that if the total amount that is given to the child 1 and child 3 is 125 together, then the split of 50 and 75 is actually consistent with the contested garment principle. What about the split between the second and the third? So together they get 150, and the two claims are 200 and 300. So therefore, all the 150 are kind of contested claims. And so therefore, it makes sense to have an equal split, which is 75 and 75. And we can do the same analysis from the first and the second child's perspective as well. So total claim is 125, 100 and 200 are the claims. So basically 25 is the non-disputed part that is going to player 2, and the remaining disputed part is equally divided between player 1 and 2. So we can see that all these three are actually numbers that we got out of this 200. This is exactly consistent with the contested garment principle, and in fact one can show that these are actually the only numbers which are consistent with the contested garment principle, right? Okay. We can also think about these other examples, right? So suppose we do the exercise with kind of the 300 case, right? So here again, you have got basically out of the 300 case, an amount that is given here based on this, and you can also think about, okay, whether this is consistent with that. Okay, let's look at a case where things are not consistent, right? So again, we are back to the case of estate value of 200, right? And suppose a split of 40, 60 and 100 is proposed, right? So this is at least, feasible in the sense that you have got 200 and this also adds up to 200. The question is whether this is consistent with the contested garment principle, right? So let's consider from the first two persons' perspective. So a total of 100 was given. And remember, the claim of the first person is 100, the claim of the second person is 200. So therefore, all of it is contested claim. And so therefore, you have got that this should have been 50-50, right? So we can see that the split is actually not consistent with the contested garment principle, right? So at least the contested garment principle explains why you got these numbers that you got here. Okay. All right. So let me just note down some results without any proof. So the first result says that, for any number of claimants and an estate in a bankruptcy situation, there always exists a share of the bankrupt estate that is consistent with the contested garment principle. So this is about the existence, right? This says that, there will always exist a share for any number of claimants and any value of the estate that you have that is consistent. The second result says that there is only one way to share the estate with creditors, D1, D2, DN, that is consistent with the contested garment principle. So these numbers that we have here for 200, these are the only ways in which we could have split this into three parts that is consistent with the contested garment principle. Now, there is another result in the textbook which we do not discuss here, which is about, okay, the first result says uniqueness, the second result says existence, but we still have not told exactly how you got those numbers, right? We have just verified that these numbers are consistent with that. So there turns out that there is a result to also kind of like figure out how to get these numbers, but we are skipping that in the interest of time. Okay, let's look at another way of kind of dividing the assets among different people. So imagine that you have got a situation where the estate is worth 250 units and the claims are 100, 200 and 3 units respectively. Okay. So now we are going to think of the situation. And again, this is a realistic situation where essentially you have a set of creditors, who are these people who are claiming 100, 200, 300. They're all going to try and like rush to the bank or wherever the amount of the worth of the estate is being dispersed. And the first person to arrive is going to get his claim in full. Okay. Because no other claims have been presented. As long as this claim is kind of like below the amount of money that is remaining for the value of the estate, this person is going to get the claim in full, right? Whereas after that, the second person is going to arrive. So again, this person, if there is enough money remaining, will get his claim in full. Or if not enough money is remaining, then he will get whatever is the remaining amount of money, right? And we'll keep on going so on. And so every creditor is going to kind of like get his claim either in full or in part, depending on the amount of money that is remaining until the estate is deployed, right? Again, this makes sense in that, we have this picture of this bank runs and so on, where this is exactly how division of whatever is the claim of the estate, or in that case, the bank, works, right? Now, crucially, the amount that each creditor is getting depends on the order of the arrival, right? And we have this basically, again, another way of kind of like splitting the amount of money among different creditors, which says that instead of actually holding a literal race, what we should do is compute all that he's going to get according to a particular order of arrival, and then take into account all possible orders, right? And then take the weighted average, where the weights are the probabilities of the different orders, right? So the amount that each creditor is going to get in the end will be the average of the amount received in all possible orders, right? So let's take a look at this game that we had. So 250 units, 100, 200, 300, right? So these were the claims. So how will this play out? So imagine that one arrives first. 1, 2, 3 is the order. So the first person is going to get paid in full because his claim was 100, there were 250 left. So then after that, only 150 is left. And then the second person is going to come in and is going to claim 200. Well, 200 does not remain, only 150 remains, but that is the amount that this person is going to capture, so that 3, when he comes in, is not going to get anything. Okay. What about if the order is 1, 3, 2? So again, 1 gets the entire 100. You have got 150 left. So 3 gets paid in full, which is 150. Remember, 3's claim was 300, but there's not enough assets to satisfy 3's claim, and 2 gets nothing. Okay. What about 2, 1, 3? Then 2 comes first and gets 200 out of the 250. Then 1 comes in and gets only 50 out of the remaining 50 that is left. So does not get the full 100. And 3 again has nothing. In 2, 3, 1, you have got 2 coming in, getting 200. 3 gets the remaining 50. 3, 1, 2, in 3, 2, 1, in both cases, 3 ends up getting the entire amount of the asset, even though that is not enough to satisfy his claim, right? So therefore, nothing is left over 1 and 2. Now you can add this up. So you have got 250 here, 550 here, and 700, and you have got 6 possible cases. So you should divide throughout by 6, and you end up getting this answer, right? So this should remind you of the way in which we calculated the Shapley value. And in fact, if you actually kind of like do the calculations, you can show that this is the same as the Shapley value of the game NV, where N is the set of creditors. And the coalition function is defined as VS, where VS stands for the estate minus the amount of claims of creditors who are not in S. Okay. Again, if this is taking a negative value, then this should be VS should be equal to 0. But if this is a positive value, then VS should be defined as estate minus amount of claim of creditors who are not in S. Okay. So this is again another way of calculating this expression that you have found here. Okay. So that brings us to the end of our discussion of some of these applications of cooperative game theory and extensions to different ideas considering different games. So we studied several games in such as dissolving partnerships. Then we studied the course game and also the bankruptcy game. And we also saw some other concepts such as core, which can be used to study some of these problems. So this is actually quite a fascinating branch of work. And there are a lot of like practical applications, right? So you will see in online markets, there are actually now platforms and algorithms which have come out with ways of figuring out how to practically divide several things such as rent, food bill, and so on, right? So Split It is an example of such a website where actually algorithms designed by computer scientists and economists have been put to use, right? So lots of interesting ideas in theory, but also lots of interesting applications. which hopefully you can pursue in a more advanced course at a later time.